Omer, ready?
Yes.
And action!
I think
action.
next time I'm going to surprise you like with the real thing they use in the movies.
Yeah, I'll
Maybe.
order one too. I'll tell my niece
Yeah.
to make me one.
Yeah.
Okay, so welcome to DevOps Topics chapter or episode number 9. Right?
Nine,
Number
yes.
9.
Mm-hmm.
And today we are going to talk about a cool subject, which is called, a cool topic, which is called platform engineering, right, Omer?
Ooh.
Platform engineering.
Yes, that's the one.
So, yeah. So as we like to start, as usual, Omer, what's the first thing that comes up to your mind when I say platform engineering? What do you think about that?
I'll address your question first because you asked what first thing comes to your mind, and the things that are coming to my mind have nothing to do with platform engineering. Because
So
it's
let
just...
me. I want to hear that. I want to hear the things that come up to your mind, and then we'll get to the real topic. Okay. So what do
Okay,
you think
the
about that?
things that come up to your mind when someone says platform engineering, platform is like this generic name of a team that every company for some reason has. We have a team that's called platform. My previous company had a team that was named platform for some reason, and it's usually an application platform. It has something to do with the application, maybe an underlying layer or something, but it had to do with the product.
I'm also wondering. Wondering about the platform that you said. So is it like also the infrastructure team, or do you have a separate team for the infrastructure?
No. It's a platform backend team. It's a backend layer that's called a platform, and it supports the product. Has nothing to do with my team or other operations engineers. Nothing. It's just a platform, the application platform. Whatever this can mean anything. It's just a generic.
So that's the first thing. Okay. Do you have another thing that comes up to your mind except from the real topic?
I have the real thing, which I basically went and read. And let's start. I'm taking a step back, like I love to do, and talking about why am I hearing this thing for so long, so many times. Not so long, I'm sorry, recently, but so many times. It's everywhere. It's on YouTube, and I've been approached on LinkedIn, and I'm seeing there's like a platform engineering YouTube channel and a platformengineering.org now, and what's going on? It's not a new thing. The term was here for a few years now. I think I've seen HashiCorp releasing material over platform engineering and have open positions for platform engineers. It's not a new thing. What's going on recently? And I don't have an answer to that. And then I went to ask the god of all answers, which is ChatGPT these days. And I asked him what's platform engineering? And he answered like the typical answer, which we'll touch on in a bit. And then I asked, why did it become recently so popular? And I wanted to hear this special answer because maybe someone is benefiting financially from promoting it. No, I got a generic answer that says one reason is that recently everything becomes cloud native and all companies are joining the cloud. So we have platform engineering now. Never mind. Do you want to hear the real thing?
Okay, the real thing. Okay, so let's cut the
let's cut the bullshit.
Let's cut it. Okay. So the real thing. What is platform engineering?
So, like probably when describing SRE or DevOps, I'll probably be crucified if anyone hears that because every engineer has two opinions over what DevOps is or what platform engineering is. But basically, platform engineering is having a team of, you can call them developers, operations engineer, which are responsible to building a platform that will help developers do their work. Now, that's pretty much what you consider DevOps are, right? It's writing the tools and creating the automations and all the systems that developers use in their day-to-day. And platform engineering is basically that, but it adds the concept of let's apply software engineering principles. Like we're software engineers. Let's build a platform. Let's build tools. Let's use sprints. Let's apply all the cycles of sprints management and everything that developers do. But in this case, we're not building the product. We're building a product that its customers are the developers of the company. That's the general idea. Make sense?
Yeah, to my eyes, being a good DevOps engineer is being a platform enginer.
Exactly. That's exactly it. And then I'm thinking
if
to
you're
myself,
a good DevOps engineer, you are providing tools. You don't want, so I always say to my developer teams, I will tell them, listen, you don't need me. Please, don't ask for help.
That's the essence.
Don't need me.
That's the essence.
You have
of
the
everything.
template, you have everything, you don't need me. Take it. If
So
you
we
have
had
issues, call me. But
we
you don't
both
need me.
had the same mentor, if you will, that always said that our goal as consultants is for the customers not to need us in the future. We need to do our work in a way that leaves them completely self-sufficient. And that's essentially the idea of platform engineering. I think the recent, if it's not like this a big financial thing and someone's pushing it for their own marketialic, whatever the term is, benefit, it's probably for the fact that DevOps and SRE, let's say just DevOps, kind of deviated into this operations engineer, YAML engineers, you know the joke?
YAML engineers.
YAML engineers, people who just write YAMLs and they upload stuff to Kubernetes, and maybe they push CI engineers, they just push Groovy code to Jenkins and things like that. They don't do the real essence of the work. I personally totally agree with that. I can say that when I first came to this, I heard about this term and then I said, okay, the new bullshit, fine. It's just another thing that people will now use. But then I kind of read a little bit further and it made sense. It clicked. And that's, I think, the essence of DevOps, by the way. Dev and Ops, it should be developers that do operational processes. And by the way, that's how I at least recruit. I'm looking for developers. I look for people that are not afraid from touching the code. I'm looking for people that can build products. And that's, by the way, what we do. We're developing tools and products that support our engineers, not in a big scale. I think Wix, the company for ages, have called it DevX, like the dev experience. So they have a team. So they have a DevX team. I just recently heard about it. So it's a team that's responsible for the developer experience. It's a group. And they're building a platform. That's what they do. A platform that will make their developers self-sufficient, meaning they can create new application environments, create new applications, create new services, deploy them to all kinds of environments, do everything as much as self-sufficient as you can think of something. Kind of Heroku, but internal, right? That you can do everything on your own without knowing, quote unquote, the underlying infra. So that's it. That's the idea. And I totally agree with it.
So I'll give an example of my experience with it. Okay, like how I dealt with it. For example, like when I think that because both of us were consultants and, our boss always told us, listen, the customer don't need you. The customer doesn't need you. He doesn't need you. Make them like independent. We don't want them to be dependent on us.
Make us redundant. He always said that.
Yeah. So that's weird. That's like antithesis, like for making money. But we made money. We were okay.
Yeah.
So one of the customers that I worked for, eventually they deployed too many things to an internal Kubernetes cluster. Too many things. So each time a developer wanted to deploy an application, it was like need to create some Helm chart and so every time you need to do the whole thing from scratch. So then I can say that, like, to my eyes, being a platform engineer or providing this type of service, it really depends on the sweet spot. So sometimes if the developer teams don't deploy too many services, I would do everything, manually. I would do that for them because, why would I start creating templates for a 1-time or 2-time or maybe 5-time thing?
But if I realize... I just want to double click on what you said now, because you said I could do it for them because it's a small team and there isn't much to do. It's not repeatable. And I think exactly that point is the beginning of every product company in the world, or every consultancy in the world, because you're thinking, okay, I have all the knowledge in my mind, I can apply it easily, but how do I do that in scale? What happens when there are 100 developers?
So when it scales, exactly. So when it scales, when I realize that it's about to scale, when I realized, as I told you, they were about to deploy many, many, many services. And then I realized, okay, doing stuff manually, doing stuff on my own, it's not gonna work. So what I did was, as I said about the Helm chart, so I created this super ultra generic Helm chart that was specific to that organization. So it's not like I can even share that code because it was specific for deploying internal services for that organization. So it had, a Kubernetes service, ingress, deployment, and everything. And all the developers had to do also a CI/CD pipeline in GitLab CI that you love. And all developers had to do was write their code, define a few things in the Helm chart, and the application was deployed and it was up. So it was like pure platform engineering. It was like 2 years ago. And I think you only get to that point, as you said, when you scale. So you need to find a sweet spot, because it's not always worth it to invest in those templates, to my eyes, because it takes time to abstract templates. It's easier to hard code.
Exactly. It's always the tension between build versus buy, which probably when you grow, it makes more sense.
Again, repeat that. I'm not sure I'm familiar with it.
Build versus buy. So
okay, I'm not familiar.
When you're small, it usually makes sense to buy things. You run on a platform, you buy AWS service, you buy servers from AWS or resources or whatever.
Okay.
You buy shelf products to do something, to help you with BI, to help you with internal communication. Use Slack, use all kinds of services. At some point, one of those services, we have some very expensive services. For example, monitoring serverless. Okay, not going to name the provider. Monitoring serverless is a hard thing to do. We use a provider pretty hard. At some point, it will probably make sense, because it costs so much money, to do it on our own, at least partially, at least one of the environments, build something on your own. So it's a kind of finding the sweet spot between, do I need to spend my engineering hours on that, or do I buy it? So that's it. And I was smiling before, because as you were speaking, I was thinking of product. So I want to try something. I want to throw out my idea and see what you think of it, because I think that's kind of touching to the heart of what platform engineering is applying software engineering to DevOps world in order to make the developer's life a lot better, but with some restrictions. So let me just throw it out there and tell me what you think.
Let's shoot.
All right. We use serverless. Okay. And that's pretty much does everything for me. I don't really have
framework.
Serverless framework, in the same way we can use SAM by AWS, or lots of other names that I forgot at the moment.
Out of curiosity, which version are you using? I think they already have version 3. Or are you still using 2.76 or something like that?
Embarrassing enough, I just don't remember. I don't remember.
So probably 2 point something probably.
Completely blackout. Yeah.
I wanted to know if you upgraded, because it sounded crazy to upgrade. Okay, sorry. Go ahead.
We have a hard time with upgrades, but we can speak about it later. There are some restrictions to that. In any case, I was thinking, okay, that pretty much does everything for me, because the developer is completely self-sufficient. They start a serverless framework, they take a template, that we have a template that they use, copy, clone, whatever, and just run serverless with whatever they need. They add their permissions, name of the service, etc., etc. Problems. They can do whatever they want. They can use an API key or not use one. They can use, last week we talked about misconfigurations. So they can misconfigure everything. They sometimes don't care about the headers that are going in. They don't care about different ports and labels. They just do stuff because they can, because that's what someone else did. At times they read the docs, 9 times out of 10 they don't, and they shoot it. Self-sufficiency problem solved. Restrictions and whatever else I can think about isn't solved. What if I were to create some kind of wrapper tool around that? It can be, and by the way, completely modular, right? It doesn't have to be the serverless framework. It can be raw creation of CloudFormation templates myself. I can do that against AWS Lambda, Google Functions, Azure Functions, whatever, or other framework. And I would let them use my tool instead of the serverless CLI, but it would be completely opinionated as to what I need. I enforce different things like using an API protected endpoint, and I would enforce the origin header to never be star, etc., etc., etc. And then I help them be self-sufficient. I'm applying the principles of software engineering. I'm applying product into that. I'm building a product that helps my developers, but on the same time, I'm doing that not in order to every Monday morning fix stuff for them or apply the YAMLs for them. I'm letting them have the power, but with the restrictions I apply. What do you think?
I'm wondering, there's always this difference. I'm not sure how to say it. I don't know even if in Hebrew or in English, but it depends what you want to create, a vaccine or a medicine, so you're trying to create a vaccine, I guess, right? You want them you are preventive. You're not healing. You're not trying to heal stuff. You want to prevent stuff.
Yeah, I want to solve it from the root.
And I think many tools and services out there that are scanning your infra and stuff, usually after the fact, after you create those headers that you said, after you do security issues, they know how to scan vulnerabilities. So now I'm thinking, with you, I'm not sure, which is better, because out there, if you take reality, there are many tools that are dealing with what you said, scanning for vulnerabilities and everything after the fact, right? After they deployed, they check the things. And you're saying, no, no, no. I don't even want to allow it. I want to restrict it even before it happens. Sounds better.
Amazing point. Amazing point. I think I have an answer that applies to me.
Okay,
my use case.
Shoot. I have no idea. Shoot.
So that's what we're trying to do today. We're trying to
preventive.
No, I mean, preventive is my idea. What we're trying to do today, because we don't have a way to prevent it, is scanning after the fact. We have already things deployed to either staging or production, and we can scan after the fact. It doesn't have to necessarily be already deployed to production. It can be scanning the merge request. It's a thing we do today, scanning the merge request to find things that we probably missed. First, not robust enough. And second, you'd always have to, as you said, after the fact. I'm creating a medicine to something that's already sick, and it's sick because the root is, it's funny to use those analogies, but the root is rotten because the template is already rotten, and every developer in my company is cloning the same project. Everything necessarily has to be scanned, and necessarily I'm going to have to find things. So I want to solve the root cause. So that's a great point, and it adds to the necessity of what I'm thinking.
So what if you said, okay, so you already gave some sort of a hybrid solution. You said, okay, so before we deploy, let's scan the merge requests. And usually merge requests are before deployment. So now I'm wondering, isn't it enough to scan the merge request and that's it? Isn't it enough for you?
It's a question. It's a question. And if I'm going back to platform engineering, to the concept, if I'm reminded of the fact that I'm building a product, not necessarily helping developers in their day-to-day, not holding their hand. I'm building a product that they use. They are my end customers. I want them to be happy. I want to add features, but I want all of them to be happy and work correctly with the product. As a team, we're building a product and serving it to our customers, and we want them to be happy, etc., etc. So I don't want to be the one that scans after the fact. I think that's kind of that's the DevOps aspect or the SRE aspect of things, but that's not the platform engineering aspect. The platform engineering is building the tool to be, it's not even preventative.
Right.
Exactly. Not preventative. It's a design tool. It helps you design your application, and it keeps you safe in the sense that I've already made it opinionated enough, so I don't have to scan and tell them, oh, dude, you have this header that's lying around and it shouldn't be like that. Or you have this port open and you shouldn't open too many ports. Or, hey, dude, I found a vulnerability. No, my tool is going to take the vast majority of things I can prevent from the get-go and let you build something that's already robust and ready for production because I made it the way I want. And that's...
But and I know that. On the other hand, again, we don't want to restrict too much. You know what I mean? Again, it's always a sweet spot. So if you build this template that you're talking about, you might restrict developers and they will be annoyed because they will be like, dude, I need this header and I don't want to tell you, please allow me, please give me a specific permission to allow this header because this application specifically needs this header. So you always gotta find this sweet spot,
So I'm going to answer exactly to that. That's the part that you apply. It's weird to say software engineering principles. It's product principles. I'm building a product and I'm listening to my customers. And we're doing exactly the same way that we build modern applications today. You have these small iterations with a short feedback loop. You ask the developers or your customers rather, what do they think of the product? What issues do they have? How are they enjoying it or not enjoying it? And then you iterate, build, release, test, etc., 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 exactly like they do with the real quote unquote product. Mm-hmm. So I think that
so another tip would be short iterations with developers. So if you take the developers as a DevOps engineer, if you take developers as your end customers, and instead of building them a YAML with 300 lines and telling them, listen, use this and that after 2 weeks of work, so instead of doing that, breaking your work to 30 rows, 40 rows, keeping them as part of your development process, and then letting them be involved. Let them use it. Be your beta testers as early as you can. Just like you do with product, just like you do with your power users.
I want to tell you a 1-minute story.
Sure. You even got 2 minutes if you want. 2 minutes, not minutes. You got 2 minutes.
Okay.
2 minutes.
1 minute story? 1 minute story. Because I forgot about it completely. 2 minutes.
2 minutes.
Back when I can't name names, it's not fair to name names, but we worked together as consultants, and one of the companies that I was a consultant on, it was a pretty long project. I was there for 2 years. pretty much part of the team. And at some point, we had a lot of issues with the front-end deployment. So after a lot of CI iterations and trying to help them with for some reason, which I'm not aware of, CI, or at least front-end deployments in my cases, are always the complex ones. Not very hard to solve, but yeah, the more complex ones. I don't know. Multiple deployments, a lot of customers, different types of front-end solutions. Never mind. I built a tool for them, and exactly like the one I said now, it was a CLI that helped them deploy. I even released it in cycles to Homebrew. We had a private app for Homebrew so they can install it on their Macs. Ooh. The ones that use Linux, I released it to Snap, and we had these iterations, and I released continually releasing features and whatever they needed. And I had a weekly chat with the front-end group leader, which was my customer, and we reviewed the product. And he said what was going well, what wasn't going well, and I took it back. I had another week of development, and I released a new version and sat with him, and we discussed it, and it went on for a few months, and they used it a lot. Probably not this day, because it has been like 3 or 4 years, coming to think of it. So that was a cool implementation of the same. That's it. End of story.
I was thinking, like, am I gonna hear but I didn't hear a but in the story.
No but. It all clicks now. No but. It worked great. I mean, I enjoyed it. Okay. I was developing a product. I wasn't like solving, I wasn't firefighting. I was developing a product that lets them, and that scales, right? Because all of them used it. They were like 6 or 7 engineers using the same tool, enjoying it.
It was a monorepo, right? I think, or maybe I'm confusing it with another product.
In that instance, yes, it was one repo, yes. Yeah.
Okay, so we'll probably also talk about monorepo in one of those sessions, because it's something we gotta talk about. Yeah, it's also related, I think,
not.
You know, it is.
There are things you don't want to touch.
Engineering, you know, it's also related somehow, because how do you design a good product? Either by creating one golden template, you know, they call it like a golden path or golden template or something, and recreate it, or use a monorepo, and then from that you start creating folders. So I wonder which is better. We'll talk about that probably in the next session.
It's explosive and sensitive to some people.
Yeah, but this is what we touch, the explosive stuff, you know? This is what we like.
Right.
Okay, so I think we are close to finish this session. So before I even ask you, I'll tell you about a crazy thing that happened to me this week. You know, before I ask you, Omer, what was your experience this week? So yesterday, I was finally able, are you ready? I was finally able to build a WebAssembly with Conan. Conan is the C++ package manager. And Diego, if you are hearing this, I'm very happy. So I was able to build the WebAssembly, the WASM Mscripten with Conan, finally, to build the application, you know, Bina AI's algorithm application to that platform. We built to many platforms, you know, iOS, Android, Windows, macOS, anything you want to build for, we built for that. So also for WebAssembly, it was tough, but eventually it worked. So I love Conan, and that was my experience this week. So Omer, what was yours?
I'll do the same trick from last week, and I said yours was good enough. Let's leave it, and I'll give mine on the next episode.
Okay. So let's have a dessert by saying thank you for everyone, especially for those who are here.
Yeah, for the entire crowd that is sitting with us.
Thank you.
In the studio.
You should put the claps, you know, like thank you, right? Do you hear the crowd? Yeah. Okay. And until next week, you know? Next week.
All right. Yeah. Okay. See you next week.
Cheers for 2-minute stories.
Bye-bye.
Bye.